Hey, so back again. This will be part 4 in my cracking on Linux tutorial series. Um, it's going to be a quick one. What I'm going to show you today is how to actually crack a program, or at least get started on cracking a program whenever there's no debug symbols. Because up until now, we've been cracking programs that have debug symbols built in, which GCC does automatically. Now, generally, I mean, obviously, if you're cracking a program, if an author doesn't want his program to be cracked, or he has some kind of mechanism to protect the binary, he's not going to include debug symbols for you. Even if they're not protecting the binary, they're not going to include debug symbols because it's an overhead they don't need. It makes the binary bloated, slower. So generally, debug symbols are never going to be left in like we've been doing. Let me just show you real quick what that is. We'll GDB login. If we break main, set a breakpoint on main, no problem. It knows exactly where main is. Now, if I strip it, so there's actually a command. Let me just show you first. It's a program you should have on your Linux box. It's called strip. If you do a man strip, that sounds kind of weird. Discard symbols from object files. So let me just show you real quick the size of login. Login is 8560. Now, if I strip it, it goes down about 2K. It goes about 25% in size, just to show you the difference. And now if we run GDB over it, set a breakpoint on main, it doesn't work. It's basically telling you main's not defined because it has no idea about main, has no idea about any kind of function in your code. There's no, it doesn't know the bounds of the functions. So it doesn't know where one function starts, where one ends. It doesn't know the name of the functions, nothing like that. So what you need to do to actually look at this code and try and crack it is try to find an entry point into the program. Now for that, there's an actual command in GDB that makes it easy for that. Info file, it'll give you the entry point, which you can see right here. This is all the section information, where one start, where it ends. But all we need is the entry point, right there. Set a breakpoint on it. Oops, I did not do that right. There we go. I don't know what I did wrong even. Oh, I see. Okay. So now we'll hit run. So it breaks in the very entry point of our binary. If we do examine, actually let me show you. Again, this is simply main. That doesn't work because again, it has no idea what main is. So let's do examine 20 instructions from the current instruction pointer. Now, this is what you generally see. It's pretty standard. What this is doing is actually setting up your environment so that you can use libc. This call right here is a function which is called something like libc start main, I believe. And the parameter here, the very last parameter, if you're on 32 bits and be pushing onto your stack, the last parameter it pushed on the stack is actually the address to your code, the code that you wrote, to your main function. So it's actual main, like this, that you wrote. So that's what we're going to breakpoint on next. Oops. Alright, so hit C to continue. There we are, breaking into there. Now again, if you see here it says in question mark, it's GDB's way to tell you, there's no symbol there. It has no idea what part of the code we're in. So again, we're going to do examine 20 instructions from your instruction pointer. And now you'll see it looks a little more familiar. Here it's setting up our stack frame. And you see a call to puts, a call to fgets, a call to string length. Now what I'm going to do is hit enter, which this is some of the next 20 instructions for us. You can see here another call to string length. This is where it's doing our little loop. Let's hit enter again. There's the string compare. So I'm going to break on that call. Go like this. So I'm breaking on the call to string length again, because by then we know that our password has been put into the pushed in the stack on 32-bit to be pushed. Again, if you're on 32-bit, the calling convention is a little different. They'll push your variables in the stack, whereas in 64-bit they put them in registers. So, but the point is, once we hit that call to string compare, we know that the environment's been set up so that the arguments are there, and we know we can look at the password. So let's put a breakpoint, hit continue, put a password in, it doesn't matter. And we're going to examine string at, where are we at, RAX. So that's the password that we put in. And so we're going to check out RDX, and there's the password. So again, this is the way. This is again, it's very basic. It's a starting point. It shows you how to get into a program when it was actually stripped. Because again, Generally, if you have to reverse engineer a binary, say you find some malware, some kind of Trojan or something on your system, and you don't know what the guy's doing. I mean, if the guy's not a complete novice, he's going to strip the binary. This is how you get an entry point into the program to actually try to reverse it. All right, so real quick one. I'm going to do another one here right after this. I hope you guys enjoyed it. I hope the sound quality is better. And have a good day.